So we were working with the trig ratios from yesterday, and that's what I just want to real quickly go back over with you and talk to you a little bit more about that and how the Pythagorean Theorem comes into play. First of all, I think the first three problems here, number 7, 8, and 9, are simple because it just wants us to label it. And you always start with either the angle that it says in the problem, or if there's like an angle listed, like the theta, that's where you start. So if I start with this angle, this is opposite. Across from the 90 is the hypotenuse, and the other side is the adjacent. So on the next one, that means I'm going to start up here. Opposite is across from it. Across from the hypotenuse, or across from the 90 is the hypotenuse, and then the other side is the adjacent. So if it just says to label the sides, that's all you're doing. Here you're starting with the angle. Opposite of the angle is the O. Across from the 90 is H, and then the other side is A. Okay? I think you know that already. Let's talk about how you use it. Again, I think you know how to do this, but we're going to go back over it so we can get to all the problems. The next one says find the value. So it says find tangent of the angle. Okay? Using SOHCAHTOA, that just means figure out which sides go with tangent. Tangent is opposite over adjacent. So think about labeling it. Opposite is across from the angle. Hypotenuse is across from the 90, and the other side's the A. We need O and A. So O and A is 8 over 15. Try 11 and 12. So number 11, sine is opposite over hypotenuse. So opposite is the 9, hypotenuse is the 15, so we would have 9 over 15. Cosine is adjacent over hypotenuse. Here's our angle. This is the hypotenuse. That's opposite, so this one has to be adjacent, so we have 16 over 20. Now, when we get to the next problems, it's a little different because we don't have all three sides. So look at number 13. I have the opposite side, and I have the hypotenuse, but I don't have the adjacent. And if I'm doing cosine of the angle, I have to have adjacent and hypotenuse. So Pythagorean theorem is when we have to do the other side to find so that we've got all the sides. So we're going to start with Pythagorean theorem. My legs are 7 and the side I want. X squared plus 7 squared equals 25 squared. Subtract that. And then take the square root. After you get the 24 is the side that you're missing. And so now to find cosine, I know I can do A over H. So I get 24 over 25. Try number 14 and number 15. Okay, on number 14, first of all, I'm going to find this other side. So we've got x squared plus 15 squared equals 5 square root of 10 squared. Be careful when you put that in the calculator. You do need a parentheses around the 5 and the square root of 10. So I like put a parentheses at the beginning and then a parentheses at the end. And then square it. And then you're going to subtract the 15 squared. And then you're going to take the square root of 25. So you get 5 for the missing side. Now, tangent is opposite over adjacent. And if this is my angle, that means opposite is 5 and adjacent is 15. 5 over 15 is okay. If you were doing multiple choice or looking at something like that, the answer might be 1/3. So keep in mind that you could possibly need to reduce some things if it doesn't come out evenly. So number 15. 14 is the hypotenuse, 7 is a leg, so we've got x squared plus 7 squared equals 14 squared. We're going to subtract where we're going to do 14 squared and then subtract 7 squared. Then we're going to take the square root of that. You can leave it as square root of 147, or we can find the decimal. Now I know that I'm trying to find sine. Sine is opposite over hypotenuse. Here's my angle. Opposite is that 12.12 that I found. Hypotenuse is 14. Again, that's probably not the way the answer might be presented to you, but if you take the choices that's given, you can figure out which one it would be. Okay, let's look at the next ones. The next ones are very similar. It's just that a picture is not drawn for you, but it's a similar information. So on number 16, it tells me that we want to find cosine, but we know what sine is. Okay, so what you do is you start by making your own little triangle and labeling wherever your angle is. Okay, I know that sine of the angle is 4 over 5. That tells me that 4 is the opposite and 5 is the hypotenuse. So if this is my angle, I know 4 is across from it, and across from the 90 is the hypotenuse. Now, my question wants me to find cosine. So after I know that information, my cosine is going to be whatever this side is over the hypotenuse. And I need to find that side using Pythagorean Theorem. It comes out to be 3, so I can go ahead and label that. We're trying to find cosine adjacent over hypotenuse. Adjacent is 3, hypotenuse is 5, so 3 over 5 is your answer. I didn't write down Pythagorean Theorem for a 3, 4, 5, just because I thought maybe you would know that one, but you can totally do it. Let's look at 19. In 19, it tells me tangent of the angle is 1. That's like 1 over 1. That's opposite and adjacent. Okay, so let's draw a triangle. 1 is on the opposite side and 1 is on the adjacent side, and I need to find the hypotenuse. So I'm going to again do the Pythagorean Theorem. 1 squared plus 1 squared equals x squared. Notice on this one I don't subtract, because these are both the legs. So I'm going to add and then take the square root. Because it's a 2, I'm going to leave it as square root of 2. And then I'm going to find the answer. The answer is asking for cosine. Cosine of the angle is adjacent over hypotenuse. Hypotenuse is what we just found. That's 1 over square root of 2. Again, that is an okay answer. It probably is not the answer that you'll see. And if you go to future math classes, it's probably not the answer that sometimes those teachers are going to want. And so let me show you that. Square root on the bottom of a fraction is not a common thing. They don't like square roots on the bottom. So what you do is it's called rationalizing the denominator. And what you do is you get rid of that square root. So that square root of 2 on the bottom, I'm going to multiply by square root of 2 to get rid of it. But if I multiply by square root of 2, that's changing the problem, so that means I multiply the top by square root of 2 also. On the top, that gives me square root of 2. On the bottom, when you multiply 2 square roots, you just end up back with itself. And now we don't have a square root on the bottom, so that's the more common way that you would see that problem. Again, I'm okay with 1 over square root of 2, but this is the more common way that's pretty much more accepted. Try number 17 and 18. Alright, so on 17, when I draw my triangle, put my angle down there, 3/5, that's opposite over hypotenuse. So that's 3 and 5. If I do Pythagorean Theorem, I'm going to get 4 for this other side. I want tangent. Tangent is opposite over adjacent, so it's 3 over 4. Right, and then this one tells me that tangent of the angle is 15 over 8, so 15 is the opposite and 8 is the adjacent. I need to do Pythagorean Theorem to find the other side. These are the 2 legs, so this is 15 squared plus 8 squared equals x squared. When you work that out, 15 squared plus 8 squared is 289. So you get 17 for x, which is our hypotenuse. We want sine, and sine is opposite over hypotenuse, so it's 15 over 17. Okay, we got one more problem I want to look at here, and then we're going to continue talking about sine, cosine, and tangent and how you can use it some more. When you have an angle and it tells you a terminal side lies on this point, what we would do first is we're going to graph it. We're going to go to -3, 4, and we're going to put a point there. Our angle goes from the point to always the origin, just the way that we've been doing it before. And everything that we've been doing, we've had a triangle. So the way that we drew the reference angles earlier, when we made the triangles, we're going to do this kind of the same thing. I'm going to make a triangle right there. So I'm going to come straight down to the x-axis. There's my 90. What's the length of this side right here? 3. What's the length of this side? That's the importance of that 3 and 4, is to know the lengths of those sides. Then you do Pythagorean Theorem to get the other side. I know that that will come out to be 5. The question says, find the trig function. So it's asking you to find sine of the angle, cosine of the angle, and tangent of the angle. The angle is always this angle down here with the x-axis. So sine is 4 over 5. Cosine is 3 over 5. And tangent is 4 over 3. Now there's one other thing I need to show you. You know how that was a -3 whenever we looked at that coordinate? That means that anything that has a 3 in it is going to be negative. The 4 is going to remain positive, and so will the 5. But anything with the 3 will also be negative, so cosine and tangent are going to be negative. So these problems, what we're going to be doing is we're still trying to find the sides. It's different from the last ones because we don't have two sides. You see, we've got one side, we've got an angle, we're looking for a side, and then there's nothing on the third side. Okay? So I can't just do Pythagorean Theorem because I don't have two sides. Okay? So this is another time that sine, cosine, and tangent are really important in a way that you can use it. First thing I'm going to do is I'm going to label my triangle. So if this is 35, this is O, and this is H. I don't have this side down here, and there's nothing on that side, so I don't really want to worry about that side. I really only want to worry about the side I want and the side that's given. So since O and H are what I'm interested in, O and H represent sine. Do you agree? So that means that I want to take sine of the angle that's given to me, which is 35, and I'm going to equal that to O over H, B over 16. Now, I'm going to use what I know about rationals and cross multiplying and things like that to solve this. So I'm going to divide it by 1. And then I'm going to cross multiply. 1 times b is b. And then this times this. The number always comes in front of the sine or the cosine or the tangent. So it'll be 16 sine 35. Now you can do this in the calculator or in Desmos. First thing that you need to know, if you're going to do it in your calculator, you need to make sure that you change the mode in your calculator. So go to mode. In other classes that I have, they might be doing it in radians, and you mightn't be degrees, so you should check it if you're going to use the calculator. Check it every day. Degree needs to be highlighted and not blinking, and it is, so that's good. Okay? Radian needs to not be highlighted. That's what it would look like if it was on radian mode. Okay? So degrees need to be highlighted. You just press enter on it and make sure it's the only one. So now we're on degrees. And then you can just put it in just like that, 16 sine 35, and round it to 1 or 2 decimal places So 9.18 or 9.2. And that gives me what the other side is. Now, some of you like Desmos, so I want to show you real quick how you do that in Desmos. Over here on the wrench, you can click on that and make sure degrees are highlighted. If you're in the North Carolina testing version, or if you're taking the actual test and you want to check and see what mode you're in, you're going to be in degrees if you're in that Desmos. But anyway, that's where it's located, so you know that you're in the right mode. And then you just type it the same way we just typed it. You can press 16. You can go to the keyboard and press and type sign like if you're at a computer. Or if you go to functions, it's under Trig. You just type sign and then 35. So you can do it in Desmos or the calculator, whichever you prefer. Okay. Questions about that? All right, let's look at number 2. Number 2. So here we have our angle. 8 is opposite. Across from the hypotenuse, or across from the 90 is the hypotenuse. Again, I don't want that side down there. So O and H are the two that's really important to me. So O and H is still sine. So you would have sine. Then you would have your angle. Which one comes first, the 8 or the C? 8. It matters which one comes first, okay? Since it's O over H, O has to come first, and O is 8. Okay? We still want to cross multiply. So put it over 1. Our C is with the sine of 67, so C comes first. 8 times 1 is 8, so we've got that. It's a little different from the one we just did because our numbers are not all together. So what we do on this one is we divide to get C by itself. So you're going to divide by a sine of 67. And still you can put it in the calculator or in Desmos the same way. 8 divided by sine 67. And you get 8.7 or 8.69. Alright, so for number 3. I'm not going to label this side right here because that's not the side I want. I want this side, that's the adjacent, and this side, which is hypotenuse. So adjacent and hypotenuse are the two sides I'm interested in. So sine, cosine, or tangent? Cosine. And then angle always goes beside of that sine or cosine or tangent, whichever. And then A over H, so D over 25. Right, put that cosine over 1, cross multiply. Is it going to be a multiplying problem or a dividing problem? Well, let's see, 1 times D is D. 25 times that. Remember, never multiply the number and the angle. It's always separate, and the number just comes in front. So it's a multiplying problem because D is already by itself. So 25 cosine 54. And we get 14.69.